Alrighty, so solutions for two variable equations. Two variables just means we have an x and a y, right? There's two variables. A solution to this pair of equation, one for x, one for y, will make this equation true. So we can start by trying the first one, which is 0, 0 comma negative 2. And 0 is our x, negative 2 is our y. So when we plug it in to our lovely equation 2x minus 3 times y, which is negative 2, equals 6. And we want to know if this gets us a true statement. Well, 2 times 0 is 0, minus a negative 6, and minus a negative, that actually becomes 0 plus 6, which is 6. This is actually a true statement right here for A. So I'm going to highlight A for us, and let me show you what it would look like if it was not true. Let's look at B, assuming there's just one answer here, which is 3 comma 2. So our x is 3 and our y is 2. So again, notice the equation that we have up at the top, which is 2x minus 3y equals 6. So we're plugging in a variable or a number for x and for y. So let me go back down here. So our x is 3 and our y is 2. So we have 2 times 3 minus 3 times 2 equals 6. 2 times 3 is 6 minus 6, and we're wondering if that equals 6. But of course, 6 minus 6 is 0, so it does not equal 6. So that would not be a point on the line. So the first point that we plugged in, 0, negative 2, does work. So you can choose that one. And I just wanted to show you what it would look like if it doesn't work. We get this like false statement, right? Because 0 and 6 are not the same. Push ahead to slide 10. So there are going to be 3 different types of solutions for linear systems. The first one is if the lines intersect once. So the lines intersect at only one point. The system of linear equations has one solution. So these two lines are never going to intersect again, only once. The second option is no solution. These lines are actually parallel, meaning they'll never touch. Think of like the two yellow lines in the middle of the street. They're never going to intersect, so there are no solutions. And the third one is infinitely many solutions. So this happens when the two lines are actually just the same line. So every point on one line is also a point on the other. Push ahead to slide 11 when you're ready. So for each graph of system of equations, we're going to say the type of system, parallel, intersecting, or same, and then the number of solutions. So for this first one, we see these are parallel lines with no solutions. I have to make that font a little smaller. There we go. These two lines are parallel and they have no solutions. They will never intersect. This next one, these are the same lines with infinite solutions, right? They are actually the same line, just right on top of each other. So every point on one line is going to be a point on the other. And the last one is intersecting lines with one solution. And we see that one solution in the graph right here at that point where those two lines intersect. Beautiful. So that's what we're doing when we're finding a system of equations. We're trying to find where they intersect, or if they do. So knowing that there are infinitely many solutions to one linear equation with two variables, let's think about what it means to find the solution to a system. So let's take a look at this system. We have y equals 3x minus 7. Oh, I'm going to take off my caps locks. Which means our slope is 3 or 3 over 1, and our y-intercept is a -7, which is the point, 0, -7. Great. Then we have another line, y equals -2x plus 3. Our slope is -2, or -2 over 1, and our y-intercept is 3, which is the point 0, 3. So now if we graph these two lines, let's see how we do. So -7 is our y-intercept for our first one, and then we're going up 3 over 1. And you can keep doing that to get a nice accurate graph, counting up 3 over 1, up 3 over 1, up 3 over 1, until we get basically off the graph. And then I'm just going to connect all my points here. Perfect. Now our second one has a y-intercept of +3, and we're going down 2 over 1, down 2 over 1, down 2 over 1. And I can kind of stop there because I already see that where they have intersected. So I can draw my line, extend it through. These are intersecting lines. Not that big. And here is my solution, which is at 2, -1. So if we plugged that point into both of these equations, we would get a true statement. That is our solution. So we just graph two lines, see where they intersect. That's our answer, right? If we plugged this in to our two equations here, where 2 is x and -1 is our y, 3 times 2 is 6 minus 7. 6 minus 7 is -1. Over here, -2 times 2 is -4 plus 3 is -1. It works for both equations. Push ahead to slide 13 when you're ready. We're going to do another one. For this one, though, notice that it's not in slope-intercept form yet, so we have to put it in slope-intercept form. To do that, we're going to divide everything by 2. 2y divided by 2 is just y. 2 divided by 2 is 1x, plus 8 divided by 2 is 4. Perfect. Our slope is 1 over 1, and our y-intercept is 4. Just going to put that over here. Our second line is 2x plus 2y equals 4. So first we're going to subtract 2x from both sides. Whatever we do to one side, we have to do to the other. 2x minus 2x is 0, so we just have 2y equals. We had that subtracted -2x and a +4. Divide everything by 2. 2y divided by 2 is just y equals. -2 divided by 2 is a -1x, plus 4 divided by 2 is 2. So our slope is -1, and our y-intercept, or -1 over 1, and our y-intercept is 2. I always put it over 1 so that, I'm just going to make this a little smaller. There we go. So that I remember to do rise over run when I'm graphing. So our y-intercept for the first one is 4, so we put a dot on 4, and our slope is 1, so we go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. If we want to go backwards, we can go down 1, left 1. Two negatives make a positive slope, down 1, left 1. And then we would connect them like so. Perfect. And our second one has a y-intercept of 2 and a slope of -1. So down 1, right 1, down 1, right 1, or up 1, left one, and then we see where it crosses. Perfect. So this has, again, one solution intersecting at -1, +3. There's our solution. That is a point that we could plug into both equations to get a true statement. Beautiful. Push ahead to slide 14 when you're ready. And remember, you can pause the video at any point to do that practice. And then this just has us doing some more graphing. So for the first equation, we have 2x plus y equals 4. So I'm going to subtract 2x on both sides. And I'll get y equals that subtracted 2x plus 4. There's our first equation that has a slope of -2, or -2/1, and a y-intercept of 4. Our second equation is x minus y equals 2. So we're going to subtract that x term. Always do that first. X minus x is 0, so we have a -y equals that subtracted x plus 2. And then divide everything by -1, so x minus 2, which means our slope is 1/1, and our y-intercept is a -2. When we graph, y-intercept is 4 for the first one, so we start here at +4. Our slope is -2/1, so we're going down 2, right 1, down 2, right 1, down 2, right 1. Perfect. There's our first line. Bloop. And then we're doing a y-intercept of -2 and a slope of 1, up 1/1, up 1/1. And we see where they intersect. And that's what we're looking for. Do they intersect? And if so, at what point? And this is right here. So our solution, since this is intersecting lines, it is at 2, 0. Beautiful. When you're ready, push ahead to slide 15. Take the notes you need, get everything you need. Okay, so for this one, our first equation has a y-intercept of -3 and a slope of 2, or 2/1. So up 2/1, up 2/1, up 2/1. Make all your points so you can draw a line. Beautiful. And our second one here has a y-intercept of 4 and a slope of -5. So we're going down 5/1, and it hits that point right there. So once we've hit a point where like, oh great, that's what we're looking for. So this has, again, one solution. So if we plug in the point +1, -1 into both equations, we will get a true statement. Beautiful. Push through to 16. So our first equation is already solved. So it has a y-intercept of -3 and a slope of 2. Up 2/1, up 2/1. There's our first line. And our second one, if we add 2x to both sides, we would get y equals 2x plus 1. So it's going to have a y-intercept of 1 and a slope of 2. So notice these two slopes are the same. This is an example of no solution because they are parallel lines. Same slope, no solution, they'll never intersect. Okay. Here's one more you can practice on your own. And then the last slide, slide 18, is rosebud thorn. And I want you to just reflect on your life and anything you want to share with me about rosebud or thorn. Beautiful, beautiful job today, everyone. You rock this. I'll see you in the next video.